Yeah. All right. So what I want to talk about today is something that we've been building during the Builders program. It's called the Zero Knowledge Hash Time Lock Contract. It's actually the stepping stone towards enabling trustless bridging between different chains that support the same hashing algorithm. So what we have implemented is actually essentially half of a bridge. So this contract enables you to do atomic swaps between two parties in a trustless way, using a predefined process that has been used in different chains for years. So let me get straight into it. So first, I would like to introduce you to why this algorithm is even necessary before diving into the implementation details. So what is the use case? What are the actors in this use case? So let's imagine that we have Alice and Bob, so the standard crypto personas, and they want to engage in an exchange of valuables, right? So we have Alice and Bob, and they want to exchange something. I assume Pokemon cards would be a good nerdy example, since we all like that stuff, right? So we have Alice and Bob, and they want to exchange valuables. So how can they approach this? So one problem is that Alice and Bob don't trust each other. They don't know each other, or maybe they know each other and they don't have a good experience with each other, right? So um, how would they exchange these valuables, assuming that blockchain doesn't exist? So if they didn't involve a third party that would be like trusted, for example, a notary service that would, let's say, enforce the agreement between Alice and Bob, they would have a problem, right? Because one of them can be not trustworthy and um, can screw up the exchange at any point in time, right? So let's assume that Bob and Alice meet up. Alice gives Bob the Pokemon card, and Bob decides to grab the card and run away. Alice would have no means of getting the card back from Bob, and that would be a problem. So this is something that not just people but also the companies face in the off-chain world, assuming they don't use a third party. So um, the next step naturally would be to include a third party. So normally this could be like a notary office that holds the value and distributes it back to Alice and Bob accordingly, depending on some written, signed contractual agreement. Um, so this is a visual example of how Dwight from the office does exchange of valuables, right? Shows up, exchanges the goods, everyone is happy, no one scams anyone. So moving on, this is a very, very simple diagram of how the exchange would look like between Alice and Bob, assuming they exchange two Pokemon cards. And we can also see how it would look like if we include, let's say, a notary service in the traditional Web 2.0 off-chain world, right? So Alice and Bob would both deposit their Pokemon cards or valuables into a third party, and the third party would then manage the exchange on their behalf. So they would both trust the third party, and that could also pose a problem, right? Assuming the third party goes out of business, etc., all sorts of things can go wrong. So what can we do about it, right? So um, thanks to blockchains, we can have a trustless execution environment for contracts. That was like the main selling point of blockchains, let's say. And there's this algorithm called HTLC that allows us to perform what we call atomic swaps. Atomic swap means that Alice and Bob can exchange value, and this exchange happens at the same time, right? So at the moment the value leaves from Alice's wallet and from Bob's wallet, new value appears, and the exchange of the goods is, let's say, atomic, right? So how does this work, right? So we move all the valuables on chain, and now we have an environment that is trustless where we can execute the exchange of our valuables. So now let's say that we forget about the Pokemon cards and we just say that Alice and Bob are exchanging some form of tokens. Since we are on Mina, let's say that Alice is paying Bob, let's say 10 Mina for some other token, which could be representing the Pokemon card, right? So Alice and Bob are still exchanging something, but now it happens on chain, and the valuables are also native to the chain itself. So how would we do this without HTLC, right? So we already said that the valuables are on chain. So we could just have Alice send a transaction to Bob and Bob send a transaction to Alice. This doesn't solve any of our previous off-chain problems. Both of the participants still can be dishonest. And that poses a problem for both of them since they still don't trust each other, right? This is what we've mentioned already. So we want to get into atomic swap instead, right? So doing a simple transaction between them, even though it's on chain, doesn't really help us or solve anything. We need actually the agreement of the exchange of the value to be enforced by a smart contract. And that is when HTLC comes into play. So this is how it would look like if Alice and Bob start exchanging stuff on the chain, right? They send a transaction to each other through a trustless third party, which is the blockchain. But we need to get into HTLC, right? We need an algorithmic way to ensure that the swap happens atomically and trustlessly between both of them, and they can be sure that they receive the value that they were supposed to in exchange for what they provide. So what is HTLC? As I mentioned before, HTLC stands for hash time lock contracts. There are two main features which are basically hidden in the name. One of them is hash locking. So it basically means that one of the parties that participate in the exchange provides a secret and hashes it, and that is what initiates the exchange. And both of the parties work from the same hash of a secret to ensure that they can both unlock the value atomically, but we'll explain that later. Another component is the time lock. So the time lock is basically like a safety mechanism which ensures that in case that one of the parties doesn't behave honestly or doesn't redeem the value that is locked in the contract, the original author can refund the value back. So it's like a, let's say, edge case coverage. So next thing I want to look into is how does the round trip for the exchange of value look for Alice and Bob, right? So implementation details for HTLC, right? Since we are on Mina and we have the native Mina token and we have custom protocol building tokens, we have two different implementations of the HTLC contract. So one of them is called HTLC Poseidon Native, which allows you to exchange the native Mina token. Another one is the HTLC Poseidon Experimental Token, which allows you to exchange the experimental. I mean, they're not experimental anymore since the last Narky release, but it allows you to exchange the tokens that have the built-in support in the Mina runtime. So the current implementation is tied to Poseidon, which is the only hashing function currently available in Snarky. However, if we wanted to elevate the HTLC implementation to a bridging contract, we would need to use a different hashing function than Poseidon, because I don't know any other chain that currently supports Poseidon for hashing, right? So we would need something like HTLC, SHA-256, or something like that in order to facilitate bridging between, let's say, Mina and an EVM chain, right? So that would be like a shortcoming of the current implementation. So how does the round trip look like? How is the contract able to ensure that both Alice and Bob can receive their end of the bargain accordingly, right? So I hope you can see my mouse well. So we start with Alice, right? Alice is the person who's responsible for initiating the exchange. And what Alice does, Alice wants to pay 10 Mina to Bob in exchange for 100 of some token, right? Just an example token. What Alice does is she deploys an instance of HTLC Poseidon Native, and she chooses a secret and deploys, or actually locks, the 10 Mina tokens together with the hash of the secret in a transaction to the Poseidon Native contract. Once Bob sees that Alice is following through on her intention and she has locked the Mina in the contract together with the hash of the secret, Bob takes the hash of the secret from Alice's contract and deploys his own contract called the HTLC Poseidon Experimental Token. And Bob takes the same secret hash as Alice has been using, and Bob locks 100 of the tokens in his contract. So we now have two contracts deployed. Both of them are holding the value that both of these participants want to exchange, right? And the contracts are tied together using the same secret hash. So that's the initial setup of this HTLC ceremony or round trip. So moving on, it is again Alice's turn to talk to Bob's contract and reveal the secret that was used to create the initial hash lock, right? So Alice calls the unlock method of Bob's contract, providing the secret, and the contract stores the secret on chain so that Bob can reuse it later to unlock the tokens from Alice's contract. So Alice knows the secret, she reveals it on Bob's contract. Bob's contract asserts that the secret is in fact the secret that was used to create the original hash lock. And once this check is complete, the contract then transfers the tokens to Alice, who is the recipient of Bob's contract. Once Bob sees that Alice has claimed the tokens from his contract, he goes ahead, and the same way as he initially obtained the hash lock, he now obtains the secret from the contract and uses the secret to do the same as Alice did, but he unlocks the value from Alice's contract, right? So he takes the secret, calls the unlock method of the Poseidon native contract. The Poseidon native contract then assures that the secret is correct and matches the hash lock, and sends Termina to Bob, who is the recipient of Alice's contract. That is pretty much it for the HTLC round trip. The interesting part is if you, let's say, draw a line down the middle, and you start thinking about these two contracts as living on different chains entirely, right? So you could have, let's say, the Poseidon native contract running on Mina, saying that you work with Mina, and you could have a different HTLC contract instance running on Ethereum, and it would allow you or enable you to start bridging value from and to Mina. So that's pretty much it. Alice and Bob have been able to swap value atomically thanks to the HTLC contract, and that's pretty much it. So if you'd like to learn more, you can take a look at the actual implementation, or we can take a look at the implementation details together.